Hello everybody, welcome back to Engineering Economic Analysis. On this video we will uh, learn about the depreciation. So we will learn the basic concept of depreciation, and then we will learn three methods of depreciation: the SL method, or the straight line; number two, the sum of years digit method for depreciation; and the third one is the declining balance depreciation. And we will not discuss the MACRS depreciation method. So we will start from the basic concept of depreciation. So depreciation is the tax a low expense deduction. So when we want to pay our tax, the taxable income is the income minus depreciation. And the process of doing depreciation is called as the capital recovery. So with depreciation, we are lowering our tax burden. And why an asset depreciate? There are two reasons. Number one is the deterioration. So that's mean the efficiency of the asset, the power of the asset, the speed of the asset, the performance of the asset decrease, and that's we call it as the deterioration. And that decrease in the efficiency, power, speed, and performance will cause the asset to depreciate or to decline in value. Number two, because that asset is already obsolete. So for example, we have an asset and there is a new technology that has just been released. So that's why our current machine or our current asset becomes obsolete, and that also will cause that machine or asset to decline in value. Okay, so the depreciation it is a tax deduction, and it is a decline in value of an asset, and the decline in value of the asset is caused by two things. Number one is because of the deterioration, and number two, because the asset is already obsolete. So that's the depreciation. So as you know, when you have a motorcycle, a laptop, so when you get that laptop, you need to buy that laptop, for example, for 10 million, but after you use it, after 1 year, after 2 years, after 3 years, the value of that laptop will not be 10 million anymore. The value of that laptop will be lower than 10 million, and that's what we call as the depreciation. And why the value of that laptop decrease? Number one, because you use it. Then the efficiency, the power, the speed, and the performance of that laptop decrease. And number two, maybe after 2 or 3 years, there is a new laptop released by the manufacturer, so that your laptop become obsolete. And because it is obsolete, the value of your laptop decline, and that is depreciation. Okay, so in order to calculate the depreciation, or to calculate the decline in value of an asset, so we need to know several terminologies. So in in calculating the depreciation, we need to know the book value of the asset, or the BV. So the book value of the asset is the remaining undepreciated value of an asset. So the book value of an asset in year one is the value of the asset in year one before we apply depreciation on that asset. So the book value of the asset in year two will be the value of that asset before we apply depreciation for that asset in year two. So we will have book value in year zero, book value in year one, book value in year two, and so on and so forth. The book value of the asset in year zero, that is just the initial value of the asset, and the book value, it is determined at the end of each year. So we still use the end of year convention. And there is also the market value. The market value of the asset is the actual amount of money that we can get if we sell that asset on the open market. And the basis, or the first cost, it is just the purchasing and the installation cost of the asset. So basically, the book value in year zero, it is just the basis, or the first cost of an asset. And then the recovery period. So the recovery period, it is the depreciable life, or the class life of the asset. So it is the number of years that we apply for an asset for the purpose of depreciation and for the purpose of tax. And then the salvage value, it is the expected trade-in or market value of an asset at the end of the useful life of the asset. So those are some basic terminologies in depreciation. So we will learn three methods of depreciation: the straight line, the sum of your digit, and the declining balance depreciation. But for all those depreciation methods, so the book value of an asset in year T, it is equal the basis, or the initial cost, or the initial value of an asset minus the cumulative of the depreciation charge. So the book value of an asset in year 2 means the basis, or the initial cost of an asset, minus the depreciation of that asset in year 1 minus the depreciation of that asset in year 2. So that's the book value of an asset in year 2. Okay, so we will start applying the first method in calculating the depreciation of an asset, and that method is the straight line method. So this is the first method that we're gonna learn. So with the straight line method, the annual depreciation charge of an asset, it is just the book value time minus salvage value divided by the life of that asset, or the recovery period of that asset. And the book value in your T, it is just the basis minus T times dt, where dt is the annual depreciation charge. So clear, it is very clear that because the book value function over here, it is just a linear function, and when you plot a linear function, you're gonna get the straight line, and that's why we call it as the straight line depreciation method. Okay. Now let's see an example. So we have an asset. The cost of the asset is 900, the depreciable life of that asset is 5 years and the salvage value is 70. So compute the straight line depreciation schedule. So that means that we need to make the depreciation table, and that table consists of the book value and the depreciation charge of the asset for all years. So we will do it from year 0 to year 5. So we'll do the first method, the straight line depreciation method. So we know that the basis, it is just the initial cost of that asset. It is 900. Okay. And the end, the life of the asset, of the recovery period, it is 5 years. And the salvage value is 70. Okay. And the first thing that we need to do with the straight line depreciation method is to calculate the DT. So it is the depreciation charge for every year. So it is just the basis minus the salvage value divided by the number of years. Okay. And this DT, it is a constant, and that happens every year. Okay. Now we're gonna make the depreciation table. So we have T. So we're gonna have year 0, year 1, year 2, year 3, and year 4, year 5. And we will have DT. And remember, in year 0, there is no depreciation charge in year 0. So DT in year 0 is 0. Okay. And we will have the book value of the asset for year T. So the book value of your asset in year 0, it is just the basis. Okay. And DT in the straight line depreciation method, it is a constant. So it starts from year 1. Okay. So it is the same all the way from year 1 till year 5. Okay. So what is your book value in year 1? It is your book value in year 0 minus the depreciation charge in year 1. What is your book value in year 2? It is the book value, it is the basis minus the depreciation charge in year 1 minus the depreciation charge in year 2. Or the book value in year 2, it is the book value in year 1 minus the depreciation charge in year 2. Okay. And because we use Excel, then we can copy everything down and paste. Okay, see. So this is the depreciation schedule of this asset when we use this straight line depreciation method. And you see that at the end of its life, year 5, so the book value of the asset equals the salvage value of the asset. Okay. Or other way to calculate the book value of the asset by using the straight line method. So it is by using this equation. So BVT equal B minus T times DT. So BV in year 0 is, it is just the basis, and BV in year 1, according to this equation, it will be the basis minus T, the year, time DT. Okay. So we copy down everything and paste, and we will get the same thing. So that is the first method, the straight line depreciation method. Now we will do the same problem, but we will use method number 2, which is the sum of years digit depreciation method. Okay. So with the sum of years digit depreciation method, so the depreciation charge, it is the remaining life at the beginning of the year over the sum of your digit. We will discuss what is the sum of your digit times the total amount depreciated. So the total amount depreciated, it is just the the basis. So the remaining depreciation life at the beginning of the year. So when we are, so for this example, we have 5 years in total. So at the beginning of of year year one, how many years that we have left? It is 5 years. If we are at the beginning of year two, how many years that we have left? It is 4 years, and so on and so forth. Okay. So the sum of your digit, it is just the total number of years times the total number of years plus 1 divided by 2. And the total amount depreciated, it is just the basis. And therefore, the dt, the depreciation charge, it is n minus t plus 1 divided by SOYD. It is given by the following equation, times the total amount depreciated. Sorry, the total amount depreciated, it is the basis minus the salvage value. So it is not the B only, but the total amount depreciated is the basis minus the salvage value. So, sorry, I made a mistake earlier. Okay, so the remaining depreciation life at the beginning of the year, it is just capital N, the life minus t. T is in what year we are now, plus 1. So for example, if it is 5 years total, so we are in year 1. So how many years that we have left? So we have 5 years, right? So when we use this formula, 5 minus 1 plus 1, it is also 5. So those are the equation that we will use, so in order to calculate the depreciation table for the sum of your digit method. And the last thing, the book value at year t, it is the basis times it is the basis minus the cumulative depreciation charge, or BV sub t equal B minus the sum of D. D is the depreciation charge. Okay. Now let's apply this method to the same example. So we will have year 0, 1, 2, 3, 4, 5. Okay. The first thing that we need to calculate is the SOYD. SOYD. So the SOYD is n times n plus 1 divided by 2. So it is 15. And then we will calculate dt and bvt. dt in year 0, it is 0. bv in year 0, it is just the basis. Okay. Now, what is the dt in year 1? It will be the remaining life, which is 5 years, divided by SOYD times the basis minus the salvage value. So we will use this equation. So the dt will be, so n minus t plus 1 divided by SOYD times the basis minus the salvage value. Okay. So we will use the same equation for year 2, 3, 4, and 5. So in Excel, we just copy it down and paste. So that is it. So the book value in year 1, it is the book value in year 0 minus the depreciation charge in year 1. The book value in year 2, it is the book value in year 1 minus the depreciation charge in year 2. So we just copy everything down. Okay. So this is it. This is the depreciation table for when we are using the SOYD method. And you can see that the salvage value, which is 70, it is equal the book value of that asset at the end of the recovery period, or at the end of year 5. Okay, so that is the method number 2, the SOYD method. Now let's see method number 3, which is the declining balance method. So with the declining balance method, so we will calculate the depreciation method by using a factor. So that factor can be 200%, 200%. When it is 200%, then we call it as the DDB method, double declining balance. So double means 2, right? So 200%, that's it, that is 2. So we call it as the double declining balance. So the factor D, when we calculate the depreciation charge, will be 2/n when we use the double declining method. Why it is 2? Because it is double declining method. So 200%, it is just 2. So when we use 175% declining balance, that's mean the factor D equal 1.75/n. So when we use the 150% declining balance, so that's mean D equal 1.5/n, because 150%, that's mean 1.5. Okay. Now this is the formula that we will use when we calculate the declining balance. So the D sub T, or the depreciation charge in year T, it is just D, that factor D, times the book value from the previous year. Or it is just DB, D times B times 1 minus D to the power of T minus 1, with D0 equals 0. The book value in a particular year, or in year T, it is just equal B, the basis, times 1 minus D to the power of T. So this is the formula that we will use when we are applying the declining balance method. Now we will solve example number 3, and I will show how the declining balance method works. So assume that we have an asset, first cost 25,000. The salvage value after 12 years, it is expected to be 4,000. So we will use the double declining balance. Remember, double declining balance, it is double, that's mean 200%, and that's mean we will use D equal 2/n, with n equal 12, so D equal 2/12. And last thing, what is the implied salvage value after 12 years using the DDB method? Okay, now let's apply this method. Okay, so we have the basis, that's equal 25,000, the salvage value, that's equal 4,000, capital N, 12 years. Okay, and we use double declining balance. So that's mean D equal, it is double declining balance, it is 2/12. Okay, now we have T, DT, and BV sub T. So the T start from 0 till 12. Okay, and DT in year 0 is 0, and the book value in year 0, it is just the basis. And what is DT? DT is D times B times 1 minus D to the power of T minus 1. Okay, so it is just D times B times 1 minus D to the power of T minus 1. That's the depreciation charge in year one. Okay. Now we will calculate the depreciation charge for every year, so we will just copy and paste everything. Okay. And the book value in year one, it is just the book value in year 0 minus the depreciation charge in year 1. The book value in year 2, it is just the book value in year 1 minus the depreciation charge in year 2. And we will copy everything down. Okay, so that's what we have. Now see, there is something here in this depreciation table. Okay, so see, the salvage value is 4,000. Now in year 11, the book value of that asset, it is less than 4,000. So what should we do? So the thing that we need to do is that we have to set that the book value of that asset in year 11 equal 4,000, because in year 10 it is more than 4,000. So in year 11 it is starting to be lower than 4,000. So we have to set the book value of that asset equal to its salvage value, which is 4,000 in year 11. So we need to replace this 364.7 with 4,000. So this 4,000 is its salvage value. Okay. So what is the depreciation charge in year 12? It should be 0. So the book value in year 12 will be the same as the book value in year 11, which is 4,000. And that is the declining balance depreciation method. However, we can have the value of D, and with that value of D, we will have the salvage value in year 12 equal the book value in year 12. So we can have the value of D, and with that value of D, the book value in year 12 will be equal to the salvage value, which is 4,000. And we can use the formula with the implied D. So implied D equal 1 minus salvage value over B to the power of 1 over n. Now let's calculate the implied D. Okay, so what is the implied D? For this implied D, okay, if we use the implied D, so it will be 1 minus salvage value over the basis to the power of 1 over 12. That's the implied D. Okay, so here the value of D, when we use the double declining balance, so this is the value of the implied D. So we will calculate T. Now we calculate DT and BVT with the implied D. So DT in year 0 will be 0, and BVT will be the same as the basis, which is 25,000. Now with the implied D, so what is DT? DT is the D, now it is the implied D, times B times 1 minus D, which is now it is the implied D, to the power of T minus 1. Okay, now we copy everything down. Now we calculate the book value for each year. Now see, the book value at the end of year 12, it is 4,000, and it is equal the salvage value of that asset. So with the implied D, we will have the book value at the end of the life of the asset equals the salvage value of the asset. The last thing that I want to explain is that we can also use this equation to calculate the book value of the asset at a particular year. So BVT equal B times 1 minus D to the power of T. I think that is it. Thank you very much.